Welcome back, everyone. So in our journey constructing confidence interval for population parameter, now we are focusing on population mean. So if I ask you to find the point estimate for population mean, you're going to take a random sample and then calculate the mean of the sample, and then you're going to build confidence interval to make sure you are capturing the true population mean. You're going to estimate population mean using confidence interval. A point estimate is a single value that estimates population parameter. The most unbiased point estimate of population mean or mu is the sample mean, which is denoted by X bar. What is an interval of estimate? The interval of estimate is an interval or range of values used to estimate a population parameter. This is what we learned when we dealt with population proportion. The definitions are the same, but since you're working with population mean, the point estimate is going to be sample mean or X bar. Now, the level of confidence is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. And remember how we constructed the confidence interval using different levels? When you have C as the level of confidence, our goal is to calculate critical values, negative ZC and positive ZC. The critical value is a value that separates the sample statistics that are probable from sample statistics that are improbable or unusual. Remember some popular level of confidence and the critical value for those level of confidence. If you have a 90% level of confidence, then the critical value is 1.645. If the level of confidence is 95%, then critical value is 1.96. And if you have a 99% level of confidence, then the critical value is 2.575. Again, if you have C as the level of confidence, it is this blue shaded area below the curve, and then these Z values, Z scores, help you to divide up the probable regions from the unusual ones. Now suppose I ask you to find a point estimate for population mean. An econ researcher is collecting data about grocery store employees in a county. The data listed below represents a random sample number of hours worked by 40 employees from different grocery stores in the county. Question says, hey, find a point estimate for population mean. So what do we have here? We have a bunch of data, 30 hours, 26 hours, 34 hours, 31 hours, 31 hours. And as you can see, some of the numbers are repeated, but the data is just not nicely grouped. That's fine with us. We're going to use our calculator and calculate the estimate here. What is the estimate? The point estimate for population mean is the sample mean. So what are you going to do? You're going to add all of these numbers together and divide by, well, we have 40 employees hours. So it's going to be divided by 40. X bar, or the average for this data set, is equal to 29.6 hours. But it doesn't necessarily represent the exact population mean. What is population mean? We only took a random sample of 40 employees. We found a point estimate. In the next step, we're going to construct the margin of error and follow the definition of confidence interval for population mean. So far, you had a sample and you found the average of that sample. In the next step, we're going to calculate E, or the margin of error. Given a level of confidence like C, the margin of error E, which is sometimes called maximum error of estimate or error tolerance is the greatest possible distance between the point estimate and the value of the parameter it is estimating. For population mean, like mu, when sigma is given to you, the margin of error follows this nice formula. E, or the margin of error, is equal to ZC, the critical value, times the error. What is that error? The error is sigma divided by square root of n. So the margin of error can be calculated by ZC times sigma over square root of n. And remember that sigma is population standard deviation. N is the sample size, and ZC is the critical value. Make sure your population is normally distributed or you have at least 30 data in your collection. So let's go back to our example before. Question says find the margin of error for the data that you collected before. Use the data below and a 95% confidence level to find the margin of error for the mean number of hours worked by grocery store employees, and assume that the population standard deviation is 7.9. So in this case, we have the standard deviation for population. The data are given to us by collecting 40 hours from different employees. Again, remember that when you have a level of confidence 95%, the critical value is 1.96. We either memorize these numbers or we know how to use inverse norm on our calculator. So let us begin. The z-score corresponds to 95% confidence level, as we know, is 1.96. We need this. Why? Because we want to calculate the margin of error. The standard deviation for population is also given to you, which is 7.9. Now, as you remember, when you have 95% level of confidence, the critical value that divides the probable sample statistic from unusual one is going to be located at the center. Well, using the values, ZC equals to 1.96, sigma or population standard deviation 7.9 hours, and n 40 people in your collection, you can basically calculate E, or the margin of error. We memorized this formula before. The margin of error is ZC times sigma divided by square root of n. So ZC is 1.96, we already know that. Sigma is 7.9 divided by square root of 40, which is approximately 2.4 hours. What's the meaning of that? We are 95% confident that the margin of error or error tolerance or the distance for the population mean is about 2.4 hours. Okay, so we calculated the distance. We calculated the error, which is 2.4 hours. What's the next step? In the next step, we're interested in constructing the confidence interval. To construct the confidence interval for population mean, when sigma is given to you, verify that sigma is there, the sample is random, and the population is normal, or you have at least 30 data in your collection. In the next step, you need to find the sample statistics n and x bar. And again, remember that x bar is the summation of all data in your collection divided by n. In step 3, you need to find the critical value, z sub c, that corresponds to the level of confidence that you have. And then find the margin of error E, which is defined as ZC times sigma over square root of n. And then find the left and right endpoint, and then you're done. The left endpoint is x bar, which is the point estimate, minus the error. Right endpoint is x bar, which is the point estimate, plus the error. Then you're going to say that, hey, the population mean or mu is bounded between x bar minus e and x bar plus e. So let us go back to our example. Use the data below to find the confidence interval for 95% confidence level of the mean number of hours worked by grocery store employees. Well, within the calculation, we already know that our margin of error is ZC times sigma divided by square root of n, or 1.96 times 7.9 divided by square root of 40, which is about 2.4 hours. Now, the left endpoint is x bar minus e. X bar, the value that we calculated at the beginning, is the average of this data set. The average of this data set is 29.6 hours. So 29.6 hours minus the margin of error, which is 2.4 hours, gives us 27.2. For the right endpoint, you just do the addition, x bar plus e, which is about 2.9. Again, the point estimate, or the average of the data here, plus the distance, which is 2.4, which is going to be 32 hours. Now, your population mean, which is mu, is bounded between these two numbers, and it can take any of these values in between these 2 hours. What are we going to say? We're going to say that, hey, we are 95% confident that the population mean number of hours worked is in between 27.2 hours and 32 hours. In the next question, a college admission director wishes to estimate the mean age. So they want to know what is the average age of the population of all students. When it says all students, it means that you're working with the population. So mu of all students currently enrolled in that university or college. What they're going to do, they're going to take a random sample of 20 students, and they find the average age of that sample, which is 22.9 years. From past studies, the standard deviation is given to you as 1.5 years, and the population is normally distributed. Question says, now construct a 90% confidence interval for population mean age. Very good. So let us begin. Remember, if you have the level of confidence, you have the critical value. We already memorized this. And since it says 90% confidence interval, it means that the critical value is 1.645. Since sigma is given to us, we're going to use the margin of error using z. The sample is random and the population is normally distributed. Use the formula for the margin of error, and n is 20. They randomly selected 20 people, and they found the average age to be 22.9 years. Sigma is 1.5. Sigma is population standard deviation. And as you know, since you have 90% level of confidence, critical value is 1.645, which is just right here. From the formula, E is equal to ZC, sigma divided by square root of n, which is 1.645 times sigma. Again, remember that sigma is the population standard deviation, 1.5, divided by square root of n. They had 9 people in our collection, which is about 0.6. So this is the distance between the population mean and sample mean. The 90% confidence interval can be written as x bar plus e and x bar minus e. The left endpoint is x bar, which is the average age, 22.9, minus the distance which we calculated just right here, everybody, 0.6, which gives us 22.3. The right endpoint is x bar plus e. Again, x bar is the average that we calculated, which is going to be 22.9. In this question, is given to us So we don't do any calculation directly. Plus E, we calculated E to be 0.6. If you add these two numbers together, you get 23.5. So with 90% confidence, for sure you can say that, hey, the average age of all students currently enrolled is in between 22.3 years and 23.5 years. So again, your population can take any value in between these two numbers. We are 90% confident about that. We don't know what is the exact value, but it gives us a nice approximation. We know that the smallest value is 22.3 years and the maximum age is 23.5 years.